Good morning to all. I am Subramaniam, working as assistant professor in SNS College of Technology. Even though I am a mechanical professor, here we are going to see in this session we are going to see about the building components substructure. So in this building components, first there will be earth will be there. Above the earth we have to do the foundations, and above the foundation we have to do the superstructure. The superstructure is give the design of the building itself. And what do you define of the substructure and superstructure? So substructure will be provided as a foundation itself, and on support of the above the foundation level will be given is one of the substructures, which gives the strong capacity for the superstructure to be withholded. Superstructure is above the ground itself, not only just above the ground itself, but above the foundation, above the foundation of the beams, which is laid on the ground itself, and we will be giving you the design, structure, and also the view of the building itself. So the foundation in the pyramid you can see, first it ensures the foundation ensures the building's overall strength. That is, before to construct a building, we have to take a foundation of up to least 7 feet to 8 feet or 10 feet itself. If it's above the 10 feet, then we have to give a pillar and also a beam around the pillar to hold the building itself, and which ensures the building's overall strength to be carried out. And next comes provides the level base of the superstructure. To next level is to which height we are going to construct the building itself. Whether to construct for the about one floor, single ground floor only, or else first floor and second floor and third floor itself. For that we have to provide a superstructure on the foundation itself. And next one is giving the prevent the soil induced structural damage itself. So on earthquakes or any other shakes, the building must not be damaged. And finally, giving the uniformly transverse weight, the roof giving the roof of the building will be given to the weight to the soil itself. It will be transferred uniformly throughout the building itself. And next you can see the foundation depth, which to which depth you have to do it. So you will be having the depth foundation is depth is greater than the width of the soil capacity. This is another full depth for deep foundation, and shallow foundation is will be having a width in the depth is less than the width and high soil capacity there. And also the shallow foundation can have the, as the name decides, the outside it will be more high strength than the inner strength itself. Here you can see this shallow foundation characteristics and usages. First, it must have a soil bearing capacity. In the earlier slides we seen about the bearing capacity. So bearing capacity means to which strength it can able to be withhold it. And the depth also will be defined. Depth and the width will be defined it. And the depth will be here this is 800 mm, that is 4 meters, or that is about 12 feet. Maximum is 12 feet, but the minimum must be about the 3 or 4 feet will be there. 3 feet is the minimum. Minimum for any building, so minimum depth must be 3 feet for the foundation, and the maximum depth can be for the 12 feet only, not above the 12 feet itself. And it is usages. What are the usages suitable for the soil conditions and also for the structural stability? Next, to what deep foundations we have to do it, and what are the characteristics there. So load transmission must be distributed along the soil itself. And also the footing width footing width and depth must be defined it, and the bearing capacity according to the soil type and structural load itself. Here you see about the difference between the shallow foundation and the deep foundation itself. So shallow foundations must be less than the width must be less than the width, depth must be less than width, whereas in deep foundation the depth must be greater than or equal to the width itself. Whereas for the soil bearing capacity, in shallow foundation it must be maximum, for the deep foundation it must be very low. And with the low transfer, shallow foundation will be directly transferred to it, to the foundation, building low transfer will be directly transferred, whereas deep foundation it will be transferred vertically. So now we can see can able to see the foundation and the footing also. So foundation is can be shallow type or depth type, whereas for the footing it must not be a shallow type. It must occupy all strength to be fitted in the building itself. Finally, conclusion of the types of foundations. So shallow foundation, depth foundation. Shallow foundation must be a strip foundation or isolated foundation and a raft foundations. These are different types of it. And whereas deep foundation, there are only two types. One is pile foundation and casting foundation. With this, we will come to the end of this session. Thank you for it.